linear equations in two variables. So now I have two variables, x and y, showing up in this equation. One of the things that we can ask ourselves in this type of situation is for instance, does the point 1/3, comma, minus 2/3, does a point, and I'm giving you one here, satisfy the equation? Alright, so let's take a look at what this is asking. As in any mathematics question, words mean something, right? I've just given you an ordered pair, an x and a y value. X was 1/3, y was minus 2/3. And I'm asking, do they satisfy this equation? What does satisfy an equation mean? Well, in mathematics it means it makes it true. Great. So let's see. Let's go ahead and plug these values in. So I have 2 times 1/3. Right, and plug that x value in for x, minus the y value. So I'm subtracting y, minus y, which was a minus 2/3. Very important to keep track of your signs in these cases. And I'm asking a question, does that equal 4/3? Well, we know how to solve this type of expression on the left. This would be 2/3. A minus is a plus 2/3. Right? Those two minuses make it an addition. Does that equal 4/3? And clearly on the left we have 4/3, and that equals 4/3. Great. Big question. Are there others? Are there other solutions to this equation? So let's find out. Here's the equation again. 2x minus y equals 4/3. One of the, probably the best thing to do to start with first, let's solve this equation for y. So I'm going to let you go ahead and do that because I know you know how, and then I'll write it down. So go ahead and pause the video and solve that equation for y. Good. You should have gotten something that looks like y is equal to 2x minus 4/3. Excellent. So the next thing we want to do, once we've solved it for y, is pick arbitrary values for x. And solve for the value of y. Alright, and I'm going to use a table, so let me do that on the next page. I've got my equation, solve for y. Y is equal to 2x minus 4/3. We'll make ourselves a table, and I'm going to do this with some x values, and here we're going to make a table like that. So I've got my x value is going to sit right here, my y value is going to be here, and my y value, I'm actually going to calculate this by whatever value I pick for x. I'm going to put it into this equation, 2x minus 4/3, and that's what's going to give me my y value. And then to the very right, I'm going to write them as an ordered pair. Alright? Now we already know one point that satisfies this equation because we found out it did early on. We said that was 1/3 minus 2/3, right? So the x value here was 1/3. And if we put 1/3 in for x and solved for y, we would get minus 2/3 if we did it correctly. How about 2/3? If I use x as 2/3, what do I get for a y value? well, I'm going to say 2 times 2/3, which is my x, put it into this equation, minus 4/3. And we'll find that we get 0. 0 is a perfectly good number. So now my ordered pair is the x value, 2/3, and the y value is 0. Let's put 0 in for x and see what we get. 2 times 0, that's easy, that equals 0, right? Minus 4/3, what does that equal? Well, again, 2 times 0, that's 0, so that just goes away, right? And I'm left with minus 4/3. So my ordered pair is the x is 0 and minus 4/3. Why don't you try 1 and minus 2 and see what you come up with. Did you get these answers? Now we have a list here of several ordered pairs on the right. And we know from the last video, or from what we studied previously, that we can plot these ordered pairs on a Cartesian coordinate system. So let's go ahead and do that. Alright, so I've drawn a rectangular coordinate system here. I haven't really labeled it yet, I haven't finished. I've got my points on the right, just to remind you. And we had our variables x and y, right? So the x is going to be put on the horizontal axis. The y I'll label on the vertical. I'm going to go ahead and say this is the unit 1, and then 2. This would be then -1, -2, and I'll just label a few of these just to get an idea of where things are on this system. So it's a good idea to start out like this. Now let's plot these points. I'll put them in orange. So remember, all of these points that we have on the right here are in the form x, comma, y. Always x and then y. That's why they're ordered pairs. So we'll start with 1/3 minus 2/3. I come over on the x to 1/3, which is about, say, here. And then I'm going to go down, because of the negative, I'm going to go down along the y-axis to minus 2/3, which puts me right about here. And I'm just going to make a point. We'll go to the next one. So we've got that one done. Let's go to 2/3, 0. 2/3, if this was 1/3, 2/3 sits about here. Remember, this is the first number is x. And 0 along the y. Oh, so it's just 0. It's sitting right here on the x-axis, because the y value is 0. Next point, 0 minus 4/3. 0 on the x-axis is right here in the middle. Where these two cross is called the origin. So the point, let me add that in, that's kind of an important thing. 0, 0 is called the origin. Okay, so let's go back. We have 0 and minus 4/3. So we're right about here. Right? Minus 4/3 is the same as minus 1 1/3, right? And then the last point we'll put on here is 1 and 2/3. 1 and 2/3. Now 2/3 I would come up because it's positive, right? There's a positive 2/3 here. So I come up here about, say, here. Great. Now one thing to note on all of these points is they appear to lie on a line. And in fact they do. So the next thing to do after we plotted the points is to, if I had a ruler I would use a ruler, but I'm just going to try and get the best line I can through these points. We would just sketch a line through the points. And we're going to assume this line goes on forever. Some people will use little arrows on either end to show that these go on forever and ever. I tend not to use the arrows, but if you would like to, that's okay. So I'm going to remove the arrows because I don't use them. Good. Let's take another look at this equation for just a minute. Our original equation was y is equal to 2x minus 4/3. This is a view of an equation, a linear equation, that's in the form y, we say it's in the form y equals mx plus b. And if you look at these, you can see that they line up. Y is equal to y, equals is equal to equals, x is equal to x. What's multiplied in front of x? M, but in our case the 2, so that would mean m is 2. There's a little bit of a problem here. These don't quite match up. And in mathematics, you might want to say b is 4/3, but in mathematics, things have to line up much better than that. So let's quickly rewrite this. Let's rewrite our equation with a plus there. Y equals 2x plus what? That's right, plus a minus 4/3. Remember this? It's all coming back, see? So now if we match things up, y is equal to y, equals is the equal sign, m here must be 2, x is x, plus is plus, and b then is minus 4/3. And it's really no coincidence that this is also minus 4/3. This was the location on the y-axis, remember, of minus 4/3. So it turns out that b will always tell us what our y-intercept is when the equation is in this form. Cool, huh?